Okay, this is Mr. Martin. These are the video notes for section 4.4 for Geometry Honors. So what I want you to do right now is I want you to pause the video and then work through examples 1 and examples 2. Um, Example 1, this is going to be a detour proof, so it's going to be a little bit long. Remember, in order to prove a perpendicular bisector, you have to, somewhere in the proof, prove it's perpendicular. And you'll probably have to do that using your right angle theorem, prove they're supplementary and congruent, and prove that PQ bisects AB, and then in the final step you'll put it all together. So quite a long proof there. And then example 2, go ahead and complete that as well. So pause the video now, and then when you restart it you can check and make whatever corrections you need to your proof, and then we will move on to the meat of section 4.4, which is equidistance. Okay, so here's the first example problem. If you got around 15 steps, then you probably did it the right way. So go ahead and pause the video as you need to check and make corrections. If you notice, we've got the first set of triangles over here. That's the whole right half and the whole left half. And then once we get to that point, you can either prove the top two triangles or the bottom two triangles. I picked the bottom two triangles just because of where point E was in the diagram. It would get cluttered if I used that. I mean, really, it was just arbitrary. So you notice I got the left half and the right half, and then I proved these two bottom triangles congruent, and I have a bunch of angles here labeled 1, 2, 3, and 4. And then 1 and 2 are corresponding parts of the big triangles, and they're also parts of the small triangles, so that's going to help us prove those. So, up to here, this is our detour. We've got two sets of triangles congruent, and then I've got angle 3 and angle 4 congruent. And remember, to get perpendicular, I need right angles, and to get right angles, I'm going to have to get them supplementary and congruent. So, in step 8, here's my angles are congruent. Step 9, I have them supplementary. So I have these two steps, which I put together to get that they're right angles. So supplementary and congruent, then they're right angles. Again, pause when you need to copy. And then once I have that they're right angles, I can say that the line is perpendicular to the segment. If a line intersects a segment at right angles, then they are perpendicular. So that's the perpendicular part of perpendicular bisector. Then I need to get that it bisects. So I'm going to use CPCTC to get that AE and BE are congruent. And once I know these are congruent, I know that line PQ has bisected segment AB. If a line divides a segment into two congruent segments, then it bisects it. So then I'm going to put, let's see, this together with this to get that. Okay, here's my perpendicular, here's my bisect. I put it together to get perpendicular bisector. And 15 steps later, we have if a line is perpendicular to and bisects a segment, then it is a perpendicular bisector. So to provide a little motivation to learn the concept of this section, the concept of equidistance, I'm going to tell you now that once we learn equidistance, this becomes a 3-step proof. So just from the given information, I would be able to say that PQ is a perpendicular bisector. So hopefully that's a little motivation for you to learn the concept of equidistance. Make sure you get help if you need it, because on a quiz or a test, if I'm expecting you to equidistance, I'm going to give you room for using equidistance and not room to do a 15-step proof. So again, pause when you need to, copy down, write questions, make sure you ask them in class, and let's move on to example number 2. So this one was not quite as long, but again, once we learn one of our equidistance theorems, this becomes a 2-step proof. You have your given, and then based on the given, we'll be able to state the conclusion. But anyway, for this one, we needed to get the triangles congruent, just knowing it was a perpendicular bisector. So we're going to use the perpendicular and the bisect parts separately. So since it bisects, I know that GF and GS are congruent, and then notice my reason here: if a line bisects a segment, then it divides it into two congruent segments. That's just the bisect part. And then since it's perpendicular, I know we have right angles. We know right angles are congruent. We've got the reflexive property. We can say the triangles are congruent from there. And once the triangles are congruent, we have CPCTC. So, only 7 steps, but again, once we learn the concepts, the two theorems in this section, we'll be able to do this in 2 steps. So that takes care of our 2 examples. We're going to go back and look at these in a minute or 2. So moving on to equidistance part 2. So just a couple of definitions and a postulate to get out of the way. When we talk about the distance between 2 objects, it's the length of the shortest path joining them. Okay, so that shortest path, really, what we're talking about here is a segment. Okay, so we just join the 2 points with a segment. Okay, segment is the shortest path between 2 points. That's our postulate. Perpendicular bisector, we already have. If a segment, line, or ray is a perpendicular bisector of a segment, then it is perpendicular to and bisects, so we actually just use that. Now, when we talk about equidistance, if you think about what this word looks like, it looks like equal distances. Okay, and when we're talking about equal distances, we're talking about congruent segments. Okay, so when you see that 2 segments are congruent, I want you to start thinking, oh, if these 2 segments are congruent, then something is equidistant from something else. So let's take a look. This example here really is just to get used to using the terms equidistant. So what we do in this example we're really not going to use in our proofs, but I think it's some good practice. So I'm going to put some tick marks here. I'm going to put tick marks here and here and here. And I'm going to look at point D, point E, and point C. Alright, so if I notice, since segment DA is congruent to segment DB, since DA is congruent to DB, again, we're just getting some practice using the terminology. This means D is equidistant from A and B. It's the same distance from A as it is from B, and we know that because the segments are congruent. And there's another way we could phrase this as well. We'll look at that with point E. So we see that EA and EB are congruent, so E is the same distance from A as it is from B. Or another way we could say this, since EA is congruent to EB, E is equidistant from the endpoints of segment AB. Okay, really it's saying the same thing, equidistant from A and B, or equidistant from the endpoints of AB. Just different ways to phrase it. So, and we also have that C is equidistant from the endpoints of AB. So in this picture, based on the tick marks, we have 3 points that are equidistant from the endpoints of segment AB. Alright, so again, if you're having trouble with this, just come in and see me for 5 or 10 minutes and we can get things straightened out. So some other pictures that you may see a lot, you know, we could have something like this and something like this. So how many points based on the tick marks are equidistant from the endpoints of segment FG? How many points based on the tick marks are equidistant from the endpoints of segment FG. So based solely on the tick marks, we see that this point up at the top is equidistant because, let's see what letter that is, IF is congruent to IJ, and J is also equidistant from the endpoints of FG. So it's the same distance from F as it is from G. So this answer to this question would be 2, and it would be I and J. Alright, if I put some tick marks on HJ and or HF and HG, then we could say that H was equidistant, but based solely on what I have so far, we would just say these 2 points. Alright, we could have a picture like this where NK and LK are congruent and MK and ML are congruent. So again, I would have 2 points, N and M. N and M are equidistant from K and L. N is the same distance from K as it is from L, and then separately M is the same distance from K as it is from L. So I have 2 points that are equidistant from the same points, so equidistant from the endpoints of this segment. Alright, so that's the basic concept of equidistance. So based on this theorem, which we're not really going to prove, we kind of have proved it in some of our example problems with detour proofs, but we're not going to go back through it again. And again, this is a long theorem, but it's not 15 steps long. So keep that in mind when you're writing out this definition. Do what you need to memorize this and also put it on your theorem sheet. So theorem 25, the equidistance theorem, says if 2 points are each equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of that segment. Okay, so a way to think about this, the 2 points determine the perpendicular bisector, would be the line drawn through the 2 points is the perpendicular bisector. Okay, so saying that the 2 points determine the perpendicular bisector means that if I draw a line through those 2 points, that line would be the perpendicular bisector. Alright, and then theorem 26 is kind of sort of a converse, not exactly. It says if a point is on the perpendicular bisector, then it is equidistant from the endpoints of that segment. So when you see this word equidistant, you want to look for congruent segments. Alright, so these are our 2 new theorems for the section. Very, very important. Make sure you do all the homework from the section and ask questions if you need to. So let's go back and let's look at example 1. And you notice I didn't leave very much space because we're not going to need it now. So I've got PA congruent to PB. I'm going to pause this now, and I'm actually just going to make another short video with these examples because I don't want the video to go over 15 minutes. So go ahead and go to the next video, and we'll finish these 2 examples. It'll only be a few minutes.